So I'm William. First, who's heard of PyTorch? Raise your hand. All right. Who is using Lightning with PyTorch? All right. And the other ones just hate it, huh? Just kidding. I'll convince you why you should use it. So let's start from the very beginning. Maybe this works? No? It's OK. I'll do it manually. All right. So first, we've been around for a while. PyTorch Lightning is something that I started working on in 2015, actually. And Theano was the thing back then, not even PyTorch. So it was actually a research framework powered by Theano at the time. And then TensorFlow came out like a year later, or even that summer. So then we wrote in TensorFlow, mostly to train on multi-GPUs at the time, right? So we were working on computational neuroscience, decoding neural activity from the brain. And we were going through ImageNet, and processing ImageNet on a single GPU through Theano was like 21 days for each epoch, which is super slow. So we built a bunch of machines in the lab and then converted all that code to TensorFlow and then distributed across GPUs and then got it down to a few hours, which is great. Like 2 or 3 years later, PyTorch came out, and if you read PyTorch, as a researcher, it kind of reads like math. So converted all that code to PyTorch. And then about a year later, I started my PhD at NYU, working with Jan LeCun and Kyung-Hin Cho. Jan's one of the founders of FAIR, Facebook AI Research, and he created like ConvNets and all that stuff. And so then I open sourced this thing, called it Lightning, and basically kind of stuck to PyTorch at that point. Then joined Facebook AI Research around 2019 to basically train models at scale. If you've been following some of the research, there's stuff that's coming out right now around self-supervised learning, coming from FAIR, actually, a lot of it. And that's under the hood, that's kind of a lot of what GPT is doing as well. So next word prediction, it's a version of self-supervised learning. So at the time, to train these models at scale, you needed, at Facebook, we were using about 2,000 GPUs per model. This is 2019, right? And these models would train for about 3 months at a time. Now, it's an internal Slurm cluster. So if you use Slurm and you use Lightning with it, it works really well for that reason. So after a few days, it would shut down the job, and then it would restart again. So we had to build fault tolerance very early on, right? I was an intern at the time. I didn't have a team, and I was super lazy, so I didn't want to monitor the model or any of this. So the model the framework became really good at fault tolerance. Like nodes would go down, didn't matter. The cluster would go down, didn't matter. It would recover, it would do all that stuff. And at the time, we'd introduce something called half precision, not us, like Apex from NVIDIA. And I'll show you a few other things, right? And basically, Lightning just became, Lightning became the way to train models at scale within Facebook. And that's still true to this day, right? So around that time frame, we standardized pretty much about 60 different teams across Facebook to use Lightning to train models. And that continues, right? So they still use it internally. They're probably they were our first like customer on that side. So many years later, created a company around it to basically bring that same capability to the rest of the world at scale, and that company is Lightning AI. So just to introduce the fact that Lightning AI is the company behind PyTorch Lightning and our enterprise platform as well. Today, we've kind of grown beyond just like a small project. When I left Facebook, I think we had about 2,000 GitHub stars. This is 2019. Today, we have about 24,000 on PyTorch Lightning, which is the bottom one. And we've also introduced a few other repos on the open source, so LitGPT, LitLlama, and then Torch Metrics, right? So he uses Torch Metrics as well. All right. So if you're using PyTorch, so basically, if you're not using any of that, that means you're training on one GPU, maybe multiple GPUs. And then you're struggling to train on multiple GPUs. Well, if you switch to Lightning, you won't struggle, right? That's kind of what we solve, generally. And you need Torch Metrics for that because how do you calculate loss functions when you have 1,000 GPUs on different machines? How do you do early stopping? Which machine do you use for early stopping? How do you save logs? How do you make sure you don't duplicate the logs? There's like 1,000 small things that go into this, right? So a lot of the libraries that we have are really for distributed training at scale. If you're training a single model on one GPU, you probably haven't heard of this, or really it's come to your attention. And if you're like, oh my God, it's too hard to go to multiple GPUs, then go to Lightning because that's how you do that. Facebook, that's how they do it, right? So what we discovered through doing this is that to train models at scale, you need a framework around it. So LitGPT and LitLlama are these repos that basically allow you to train any LLM, right? So they're not models. So LitGPT, you can drop like all the open source models, in Pythia, like, I don't know, Llama, all these things that come out. And that framework is optimized. So we fuse all the kernels, we work with NVIDIA, we work with Google, make sure all the operators are implemented correctly, so they'll run really fast on TPUs and GPUs. We have tight partnerships with these companies, so they're very, very profiled and optimized. So let's kind of explore a little bit of the growth. It's been 3 years, I think, since, or 4 years, I guess, at this point, since we open source Lightning. We've grown to about 73 million total downloads, actually 76 now, I think. So it's about 4 million downloads a month, trending up for sure. Over 24,000 projects in the open source use Lightning. This represents a small fraction of all projects because 99% of code is not open source, right? If you're at a big company today and you have more than a few people, it's very likely that you use Lightning to train those models. Now, Lightning is not limited to training. You can deploy with it. You can do anything that PyTorch can do, right? It's just a simple way to do that. And we have many communities, right? So we have Discord, Slack, a few others. We host events routinely in New York and like San Francisco. And I think our last, we did one with Stability AI a few months ago. We had about 1,500 people in that event, right? Then we do like random mixers, rooftop things where you get to meet the community. Those average like 300 to 800 people usually in New York and SF. So definitely come out if you're around for one of those. So this is another interesting stat. So 40% of PyTorch users use Lightning with it. That's a lot of people, right? And this number grows a lot. I'll show you why, like what the analogy is for this particular thing. Lightning is used in about 10,000 companies across the world. This is the open source, right? And a subset of these people are getting onto our enterprise platform today to train and deploy models and more than that, right? If you look at the individual, so 73 million downloads, that doesn't mean that 73 million users, right? It means that people can install things multiple times. So it's roughly 1 to 2 million users across the world use our stuff. Here's an article from 2020 that talks, like Facebook put out, that talks about how this restructuring that we did and how we standardized all these teams on Lightning. They talk about how they did that and why, right? But TLDR is if you have 60 teams and they'll write their own versions of PyTorch and their own trainers and their own ways of serving, none of the code is interoperable, none of it works together. One engineer leaves that team and then suddenly that code base is no longer good. So they knew that issue back in 2020 and so they standardized across. Lightning gives you a standard, it's an interface, right? So it allows you to make things modular and make interoperability work really well. So that's the first thing it does. We kind of got stuck in the Gen AI explosion because I think Stability AI, like they basically blew up over the summer, like 2021, I think when it was. And then everyone learned what Gen AI was because of this, right? Stability trained all their models using PyTorch Lightning, right? If you're doing anything at scale, this is the way to do it today. We gave a talk at Google Next a few months ago about how we accelerate workloads on TPUs as well. So we partner with the TPU team at Google. They basically make XLA work really well with Lightning, not just PyTorch. And it actually allows our customers to not be locked into GPUs or TPUs. So if you guys have ever tried this ability to train between CPUs, GPUs, and TPUs, this is something that we pioneered in 2019. And then it actually got adopted across industry after that, right? And I'll show you how we did that. So again, just some of the growth. It's also a big community of contributors. We did the math, and it's something like 300,000 hours put into PyTorch Lightning on the open source throughout the community and everyone here. You can try to build your own, and people have tried. Facebook tried, Lyft tried. It doesn't work out. It's extremely hard to do because it's not just about a training loop. It's actually about how do you integrate to loggers? How do you integrate to hardware? How do you go between GPUs and TPUs and all of that? How do you make sure that it works for NLP, computer vision, reinforcement learning, meta learning, any type of thing you're going to throw at it? It's extremely hard. You might be able to build a very specialized version of it, but it's going to be too bespoke, and you're not going to benefit from the open source contributions. So in Lightning, you'll find QLoRa, you'll find 8-bit precision, 4-bit precision, all that stuff that gets out of the box. You're not going to sit here and do that for multiple months, right? We work with those teams to do that and put it into the open source for everyone. I went on GitHub and just kind of searched for random companies. I just put Microsoft on there to see how many projects I have that use Lightning. 28 projects that they've built, and these are non-trivial projects. Like some of these have a few hundred GitHub stars, some have 10,000, 20, 16,000, 6,000, 7,000, right? So Lightning is also powering other big communities under the hood. So this is just one example, and I invite you to do the same. Who knows about NeurIPS? All right, big AI conference. This is the top AI conference for researchers. This is where you're going to know what's going to happen in the next year. This is where things get announced. Like Stable Diffusion was at NeurIPS 2 years before anyone knew what it was in the regular world, right? They have an LLM challenge to train LLMs on one GPU one day. The whole community is trying to figure out how to train LLMs in like a few $1,000s, including us. So this is a challenge for research community to figure this out. The code that they give you to start is Lightning code, right? Because it's already been optimized aggressively by us, NVIDIA, Google, et cetera, to do this kind of thing. So if you take nothing away from this, other than we are all working to making you be able to train LLMs and models extremely cheap, and today we are leading in a lot of those categories as well. Okay, so let's talk about some of these actual optimizations. So what does this look like? So this is in June 5th. Falcon 40B is a model trained by the UAE, I think, came out. That next day, we just ported it over from PyTorch to Lightning. Just by doing that, we made it 20% faster. How? Because there's a lot of things that you're going to mess up in your training loops, how you, like when you save checkpoints or you don't save them, how you do the backward or forward, what order, and so on. Do you use CUDA graphs or not, this and that. All these tricks, it's like thousands of them, are just embedded into the framework already. So unless you're like an expert CUDA engineer from NVIDIA, it's very likely you're not going to have those things, right? So basically, just by doing this, we got the speed ups. Then we move on. So around the same time, Falcon 7B came out, and then we measured this, right? So if you were to train the model without Lightning on basically, yeah, the whole thing, 6 GPUs, it would take you about 8 hours and 52 minutes. Once we just got done with it, we did a few optimizations. We added LoRa, we added a few other techniques to it. We were basically able to get it to basically about an hour and 1 GPU, right? So it's a massive, like this basically means that it's going to be 9 times 6 times 54 times cheaper, basically, at the end of the day, to train with Lightning. Okay, we have a PyTorch team internally. So we hired the person who was the head of PyTorch at NVIDIA, who then got hired at Meta to lead the core PyTorch team. So PyTorch itself is about 100 people. About 8 of them are like the core people. They're the ones who write the optimizations, Torch 2.0, Torch compile, all that stuff. So we hired the head of that team. He came into our company. We also hired the head of the profiling team at PyTorch, and he used to be the profiling guy at TensorFlow before that. And then a few other people on the team. So that team is basically working on how do we make optimizations that are faster that you may not even find on PyTorch itself, right? And PyTorch has a lot of stuff that it has to deal with that are things that we don't have to deal with as well. So he sat there and we were basically trying to train, I think it was a Falcon model, and he did a talk, and basically what he noticed was, because he'd been on TensorFlow before, he noticed that when you were doing the forward pass here on the left side, you're basically accumulating a lot of memory. So that purple thing, you're basically accumulating a lot of this. And when you do the backward pass, it wasn't being released. And that was weird to him because in TensorFlow, you actually do release the memory as you go through the backward pass. What this means is that there's an overhead of about 25% memory inefficiency in the models that none of you are looking at because none of you are like going into PyTorch and like looking at the details of this thing, right? So then he looked at it and he's like, yeah, that's kind of silly. So he basically wrote in like a weekend some hook to basically release memory in the backward pass, gave you a 20% improvement in memory. That's it. That means you can train a larger model at the end of the day, right? So that was very fast. And we landed this on the open source, so you'll get that today in Lightning. This is not available in PyTorch, for example, right? So there are certain optimizations that you're getting now by using Lightning itself directly. We may upstream a lot of this stuff to PyTorch at some point, but at the end of the day, these things live on the open source as well. So here's another example. So this is, again, this is the Llama model, I guess. And then on the right side, we're using Fabric. And all we did was basically just enable 16-bit precision. Now we support 8-bit and 4-bit and so on. Point is, you don't need to know what any of this is. You just turn it on. And here's the change, right? It basically went from about 40 seconds and about 30 gigs to about a few seconds and like 12 gigs. So that means you need smaller GPUs, means you don't need to run an A100. I don't know why everyone's obsessed with A100s and H100s. If you know what you're doing, you can get the same thing on A10Gs, right? Or T4s. It's just that everyone's like obsessed and they don't want to do the work to reduce the memory for some reason. Like, I don't know, this is pretty easy to do. So we have a lot of examples like this as well. And on our platform, there are a ton of these where you can basically just turn them on and be able to train these models really, really cheap with lower memory as well. So basically, if you want to keep paying for A100s and H100s all the time, that sounds great. But if you want to be smarter about it and use GPUs that are actually available, there are other techniques that can get you there as well, and we can help you do that. So to be able to train a model really, really well at scale, you need to basically solve all this stuff. And when I say train, I also mean serve. Serve is a subset of this. Serving is a much easier problem than training a model, right? So you need basically a way to have this like AI application layer on top. Like, is it going to be a Streamlit or a React app? Or like, what's the front end? Is it an API? Is it a notebook? What is it? Then under that, you need orchestration, right? Then you need the model itself, kernels, the accelerator, the data, how fast do you get the data, how do you process the data, the networking, and the infrastructure. So everything on here is handled by some part of our stack. So on our enterprise platform, we basically take care of all this stuff. And then we have open source specific like tools that basically sit at each particular layer here as well, right? And then they basically can help you optimize these different things. But if you want to have the fastest models out there, not just because you're like trying to be cool and have a fast model, but because it'll save you like millions of dollars, then you need to solve all these problems. And you usually won't be able to, right? Usually you'll grab some code from some place that has a model, then you'll load it and put it into PyTorch, and you're like, great, my model's training. Okay, so you solved 1 out of like 10 problems. Good for you, but there's still a lot of other stuff that you're not doing to actually get the most out of that. So again, I just talked about what is PyTorch Lightning. Here's my analogy. So PyTorch is like JavaScript, and PyTorch Lightning is like React, right? Like, yes, could I build Facebook using JavaScript? Of course you could, but why would you, right? And would I build my own version of React internally? No. But every single person that is not using something like Lightning has built their own version of checkpointing, has built their own version of changing machines, integrating half precision, et cetera, et cetera, et cetera. Then that PhD leaves, and now you're stuck with all that code. You don't know how to change it. Then tomorrow, Kilora comes out, and you're like, how do I bring that in? So it's a whole problem. So point is, the world has to evolve, and we've already seen it through the web development world. We went from just using Ajax and JavaScript to using things like React, right? Because they scale better, and they're built by a community as well. So it's just a maturity part of the curve. Again, the example, it's like, yes, you can use JavaScript to build something like that on the left. Building something like this on the right is going to be extremely hard to do using these basic building blocks. So when do you want to use Lightning, right? Basically, and this is kind of like more applicable to startups or like new projects. Look, if you're gonna build a new product, my suggestion actually is to start with like an OpenAI API or something, like some API out there that you can just hit immediately and start prototyping. Get to someone who's paying for that product, or get to some sort of product market fit with that, and then figure out, okay, do I have enough data to then train my own model, fine-tune it? And you probably will at that point, and you probably have collected it through your product. Then you bring Lightning in, and at that point, we can help you fine-tune or pre-train, right? And then after that, when you need to actually do this at scale across teams, you need to deploy it, you need to manage costs on the cloud, all that stuff, that's where the platform sits, right? So this is kind of the suggested like evolution that I would say to people today. Okay, so let's talk about the Lightning platform, right? So it's an end-to-end platform. It is probably the first end-to-end platform. Everything that is out there only does one thing today. They either train, or they serve, or they do data processing, or they help you build apps, or this or that. That's great, but why would you want to buy 30 different platforms, right? It's kind of weird. So what we built, and it took us about 3 years to do this, is really an end-to-end platform that can do pretty much all those things today, right? And it's all unified. And it's exactly the same philosophy that we apply in the open source. We want to give you a simple interface that can do all of these things. It's not easy to figure out how to get Kubernetes to work properly and this and that. It takes a lot of time to do this correctly, right? So we see pretty much most of our customers have tried to build a version of this themselves. Usually they fail, and they string together a bunch of different platforms. It doesn't work out, and then someone leaves, and then you're stuck maintaining that, so it's a problem usually, right? So that's kind of when we come in to replace a lot of that, or even augment the current platform that's there. You can pick these capabilities, really, and you don't need to like grab the whole platform. You can grab, hey, my serving thing's pretty good, but I do need something for training. Then you can grab the training piece, drop it into your pipeline. So you can pick and choose the parts that you care about as well. You don't have to like necessarily do the whole thing. So I'm talking about one particular capability, which is really training LLMs. So I already told you in 2019, I was already doing this. Today, everyone's like, oh my God, how do I train on 30 GPUs? Well, it's not that hard if you've been doing it for a while, right? So all that knowledge is already embedded in here, and this year everyone started knowing what an LLM was, which is great. So really the first capability that's probably more applicable to people today is, hey, you can train an LLM. And what I mean by this is you can grab an open source LLM or bring your own or make your own or whatever and fine tune it or train it. That can be on 1 GPU or 1,000 GPUs. That can be on a few megabytes of data or a few terabytes of data as well. It really depends what you want to do. The pattern that we see is people will grab an open source model, they'll drop it in, see how it works, and then they'll give it a little bit of data, fine tune it, see how that works, deploy it, get some feedback, and then continue to iterate before they invest into more training. Whether you fine tune or train, pre-train, it really comes down to how much data you have at the end of the day, right? I already talked about stable diffusion, so you can go to all the stability repos and see how they use lighting at scale. Here's a few other examples. So there's these models called Hyena and RWKV, which you may or may not have heard of, but these are kind of the next thing in research. These things will probably take over the next few years as well. These are already built from the research community using Lightning today. So that's already out of the box. OpenFold, so this is another project that's built using PyTorch Lightning. And then there's NeMo from NVIDIA. So NVIDIA itself, so we're really, really tight partners with NVIDIA. So NVIDIA basically has a whole suite of software tools, to train models and all that stuff. All of that is built using PyTorch Lightning under the hood as well. And we collaborate with them. Again, they are making really crazy optimizations to make sure these things run really tight with GPUs. And those are being upstreamed to the PyTorch Lightning framework and the platform as well. So you get all this stuff out of the box. Yeah, I already talked about these guys. Okay, so what does PyTorch Lightning look like in code? So this is it, right? You have two things. You have this class, this Lightning module, which is here. So I'm gonna, this thing here, Lightning module. And it's got a few methods: forward, training step, and then optimizers. Training step is where you do the logic. This is 99% of the code you need to change. That's it, right? If you don't believe me, I'm telling you, there's thousands of examples that show NLP, computer vision, reinforcement learning. Every single use case can fit under this pattern here. And then you have the trainer. The trainer, this object here, this is what scales across GPUs. You can then say, if you look at this code, there's nothing about GPUs on here. There's no CUDA calls. There's nothing about moving memory around, none of the stuff, right? So you get to write plain PyTorch. It's just PyTorch. It's just really organizing your PyTorch code. That's all it is. But it's still PyTorch. So you still have full control over it. But when you run it, if you run on a GPU machine, we'll automatically scale to the GPUs. That machine has 8 GPUs, we'll scale to 8 GPUs. You run it on the platform and you've plugged in your accounts and all that. You need 1,000 nodes, cool. It'll just scale itself to 1,000 nodes as well, right? So it does not matter what you're running. Oh, you want to run it on TPU? Sounds good. There's an argument in there called TPU. And you just run it on that. You want to run it in Gaudi. You want to run it on GraphCore, any other accelerator, right? It'll just work on those out of the box. You want to use FSDP. You want to use deep speed. You want to use any of these strategies. They all plug in here as well, right? You want to use 8-bit precision. So all of that happens through the trainer, all these optimizations. Some of you, and here's some examples, right? So if I want to run on 4 GPUs, this is what you do. Devices 4, accelerator 4, and you choose the strategy. Or you can write your own strategy, right? Most people who write their strategies are NVIDIA or Facebook. That's it, usually, right? Now, some of you may have amazing teams internally that really know how to distribute stuff. You can have full granular control over exactly how you do that. And then you have all these other helpful things that you're probably never going to build for yourselves because they're pretty annoying to build. How do you know your model's working? Well, why don't you just overfit one batch? Just turn that on, and it'll take the whole data set and try to overfit in one batch. If you can't do that, then your model's probably not going to work for the larger data set, right? What if you want to only run for so many epochs or min epochs? Or what if you want to do a dry run before you go spend $10 million on a model? Run through it once and see if it's going to crash anywhere. Because usually what will happen is you spin up the model, and then 2 days later it crashes in some dark validation loop somewhere, and you just spent $300,000, right? All of these things are out of the box solved here. And you can chain these things together. You can do static, stochastic weight averaging, blah, blah, blah. You can write your own callbacks. So it's an operating system. That's what it is, right? It's not just a way to train a model. Now, if you are an expert and you know exactly what you want to do and your training loop is super bespoke, then we offer you basically a gradient of options. You don't have to just take PyTorch Lightning. You can actually opt into pieces of PyTorch Lightning along the way. So the first piece that you can opt into is this thing called Fabric. right? So Fabric looks exactly like PyTorch, but you change like 3 lines of code here. So you basically initialize the Fabric object here. This is where you would say how many devices or GPUs or TPUs you want to run with. Then you launch it, and then you just set up the model and the optimizer. You get that here. And then you set up the data loaders, and then the rest you own. The only change is that you have to call fabric.backward instead of torch.backward, right? Or loss.backward or whatever. So that's it. The rest is PyTorch. Like 99% of this is PyTorch now. So you can fully build your own trainer is what it comes down to. You can build your own way of training models. And you don't have checkpointing here, so cool. You can import our checkpointing or build your own. But ours will work across distributed devices, right? So it's like fault tolerant, all that stuff as well. Oh, you don't have logging, that's fine. We have loggers in there you can bring in. Oh, you want to use callbacks as well? You can still drop them in here. Oh, you still want to use the Lightning modules? You can still use them here, right? So you can build in pieces of this as you go along. Again, this is really for experts, and it's for people who like need granular control over something that they're doing. This might be like meta learning, reinforcement learning in specific cases. Maybe you're training GANs, that kind of thing. Or you need to like distribute groups, for example. So some features in Lightning 2.1 that just came out like a few weeks back. So you can train multiple billion parameters with FSTP. There is a partner of ours that's training a model today in about 10,000 GPUs that will be announced in the next few months. Probably one of the largest models to be trained on that kind of compute, and that's using Lightning to do that as well. Better ergonomics when you scale up your models, right? So it's going to feel a lot easier. It's going to be less cumbersome, and you can actually read the code. That's a big thing for us. We want you to be able to go into the framework and read it. And you can pre-train. Yeah, there's like a lot of these new optimizations around using 8-bit, 4-bit precision. So all these things mean you can basically just have more parameters or use smaller GPUs. So it means you can have bigger models or save a lot of money on the type of GPUs you're using as well. That's what all that means, right? Yeah, so the rest, we have a few minutes left for questions, but I do encourage all of you to scan this and sign up for the platform today. We do have a wait list of about 25,000 people today, but we will definitely look through it from people you're signing up, and we will try to get you off if we feel like we can help you today. Anyways, thank you guys. Appreciate all of your listening. All right, any questions? Yeah.
Do you support MIGs or multiple CPU splitting? So versus enable how many put in seven pieces?
Yeah. I don't know if we've done that formally, but it's a pretty simple thing to enable, yes. Yeah. For like serving, you mean? Like you want to serve on different? Yeah, for sure. Yeah, as long as you, so we're going to do that through your cloud. So you're going to basically connect your cloud account, and then we're going to set that up through that on the platform. But yeah, we can definitely look at that. Anyone else? Yeah.
Lightning user from Meta here.
Oh, nice. How do you like it?
Love it. So my main use case is offline inference for knowledge foundation.
Yeah.
Wondering if, so this is training groups, is that test you individually try to collect the outputs from the model for distributing? Sure. I was just wondering, like, have we considered beyond training as also a main use case?
Yeah, 100%. So like I said, we focus a lot on training, but like if you can do it with PyTorch, you can also enable it. So we've enabled things like export to Onyx, Torch serve, all these different things as well. The platform actually has all these things more integrated in it. We do some edge device stuff, but like we haven't incorporated the latest things for Meta. I was just at the PyTorch conference last week, and this execute torch and things like that, we're definitely going to be integrating a lot of that as well. Yeah, but come by and definitely let us know your use case. So, cool. Anyone else? All right. Well, thank you guys. Definitely try Lightning, and I'm telling you, you're going to be like training multiple GPUs. You're going to be like, wow, I can't believe I waited this long to do that. It's not that hard. I promise it just works out of the box. Anyways, thank you.